Hello everyone, welcome. Myself Mohammad Nazar. These are my teammates Gopal Krishnan and Abhijit. We are from EC department in Tech High Tech Engineering College. Our project title is Generalized Equalization Model for Underwater Image Enhancement.
Started. Let's get into our project. Uh, Thanks to our internal supervisor, Ms. D. Shofia Priyadarshini ma'am, Assistant Professor, Department of ECE. Now let's see our abstract. Our abstract explains about the underwater images are essentially characterized by the poor visibility because light is exponentially attenuated. The light is exponentially attenuated as it travels, and since result poorly contrasted and hazy, it will contrast in hazy and contrasted and poorly contrasted and hazy images. In this project, to overcome that, we propose a generalized equalization model for image enhancement. Based on our analysis, we take these different relationships between image histogram and contrast enhancement or white balancing, we can say. We first establish a generalized equation model. Integrating, that means increasing the contrast enhancement and white balancing into a unified framework of convex programming of image histogram. Then subjective and objective experimental results show favorable performance of this proposed algorithm in applications of image enhancement. That means in white balancing and tone correction. Okay, next we see the introduction of this project. The introduction varies in real-time applications. Like this image enhancement is for aesthetic and pragmatic purposes, like arts and culture. It is used. In fact, this algorithm has been widely applied in image devices for tone mapping. This algorithms, enhancement algorithm, is already applied in imaging devices for tone mapping. Okay. Then the visibility range is increased, can be increased with the artificial emission of light on the object, but there's a slight error that it produces non-uniform of light on the surface of the object and producing a bright spot in the center of the image with poorly illuminated area surrounding it. These are the background areas which the light, it's a uniform non-uniform of light produces. Okay, so it focuses on a certain spot in center, and the background will be in a poor illuminated area surrounding it. Objective of the project is to improve the visibility. Objective is to improve the visibility and quality of underwater images, and to enhance the contrast and brightness of underwater images, and to reduce the effects of light attenuation, turbidity, and color distortion on underwater images. Okay, next the existing system will be explained by my teammate Gopal Krishnan.
The existing system of this project, um, they have two challenging problems for image enhancement are not still solved. Application of image processing algorithm to understand image result in unrealistic pictures with a non-uniform scene lightning. Then underwater image enhancement is important for image capture, often suffer from color cast, low context and dedicated visibility is due to the absorb and scattering of lighting in water. Then drawbacks of this project, underwater images are essentially characterized by poor visibility because light is essentially attenuated as it travels in water, and the scene result poorly contrasted and hazy. The visibility distance at about 20 meters in clear water and 5 meters of less in turbid water. When we go deeper, and the color drop of one by one depending on the wavelength.
Okay, now I will explain the proposed system. The proposed system is what we proposed in this project. Despite of the abundant literature on the Android image, the two, as we seen the existing system explained by Gopal, so two challenging problems for Android image still not solved. To achieve this, how to achieve first the contrast enhancement while preserving a good tone. Second, how to theoretically relate different types of enhancement algorithms to each other. By correcting this algorithm and preserving a good tone, this can be achieved. Like we said in the first abstract, we proposed a generalized equation model. Analysis relationship between histogram contrast enhancement or white balancing. We first established a generalized equation model integrating contrast enhancement and white balancing into a unified framework of convex programming of image histogram. Next, okay, let's see the block diagram. This is the main theme of the project. In the input image, we are taking an input image from the underwater or deep drives. Conversion, then we are converting it from RGB to YCBCR. YCBCR means it's a lumina brightness. We are converting these colors to a brightness color, and by using homomorphic filtering, anisotropic filtering, then we are reducing the noise by denoising method. Then again we are converting from YCBCR to RGB, then equalizing the color mean, then we will get an enhanced and denoised image, an output image. Okay. The advantages of this image improvement techniques are applied to get rid of image noise and improve overall image clarity. Then underwater image improvement finds plenty of application, multiple range of diversified fields. It finds use in examination of underwater infrastructure and reduction of any unreal projects. Okay, finally we are going to see the result. This is experimental result. Actually, we are using an simulation tool in MATLAB, the experimental tool for simulation. It is varied on. It is varied. It is achieved at PSNR. PSNR means peak to signal noise ratio, ranging from 30 dB to 60 dB decibels. These noise powers are changed from 0 dB to 15 dB. Okay, these are the things we are changing. So the output, as you can see, the original image is like this. Then the initial background, it is taking the initial background and secondary data, and it is providing an enhanced image. These are the values of the noise reduction in dB. You can see in the left side. So these are the PSNR and MSE values. MSE means mean square error values, and peak to signal noise ratio values is based on each noise power value. So thus the proposed work consists of the below error rate and accuracy range. Thus the enhancement technique can be carried out with higher accuracy range. Okay. Next, next is the output. This is our final output. This is our code, as you can see. Contrast weight map. So I am running the code. You have to select an image now. So we are selecting an image. This is the original image. These are the initial contrasts, figure 1, figure 2, figure 3, and it is the enhanced image that we got from this figure 1. As you can see, all the enhanced outputs from here. Okay, this is the final output from this image to this enhanced image. You can see the difference I think so. Okay, coming to the conclusion, by concluding this, we can, let's conclude this. Okay, in conclusion, we are concluding by saying that this consequence of noise blurring, restricted visibility on image will thus be reduced. So, in order to improve the perception, image waters are post processed to enhance the quality of the image. So, subjective and objective experimental results shows favorable responses of the proposed algorithm in applications of image enhancement, white balancing, and tone correction. Computational complexity of the proposed method is also analyzed.
These are our project explanation. Thank you for giving us this opportunity.
Thank you.